So two-way frequency tables seem quite complicated, or they get quite complicated, but really all you need to do is just understand what it is that you're being asked and how you can use the information in the table to find it. So the first part of the lesson talked about finding the total values for the events. Now, being male is an event, being female is an event, because it's an option that you could have, it's an outcome that you could have. You could be male or you could be female. And having an SUV or having a sports car is also an event, because you could have either an SUV or you could have a sports car. So you can see by the cells in the middle that there are 4 possible events, and you can back that up by counting these rows and columns here. So if we wanted to know the total, if we wanted to know the total number of males who were asked in our survey, 21 picked SUV and 39 picked sports car, so we know that the total is 60. Same with the female, 135 picked SUV and 45 picked sports car, so we know the total is 180. So we know that our columns add up with the totals at the bottom, and our rows add up with the totals at the side. So that's quite straightforward and easy to understand. But what about if we want to know if they were male and picked, say, an SUV? So we need to know where the row and the column intersects. And these are important words because they're used a lot in Venn diagrams, which we will go on to later. So it's really important that you begin to understand what these words mean and that we start using them. So the intersection is basically where does the column and the row cross each other. So we're looking for SUVs, so this is the column here, and we're looking for males, so this is the row here. So we can see that they cross at this point here. So likewise, if we wanted to know the total who were female and liked sports cars, so we have the female row here, and we need to know the intersection. We have the sports car here, so where these two cross, where the row and the column cross, is this point here, so we know that the total is 45. Now the next part is asking us the number of females or preferences for sports car. So basically the combination, the union of the two sets, and again union is another word that we will be using when we look at Venn diagrams, so it's something that you need to start kind of getting your head around. Now it's easy to see that the total number of females, so that's this row here, is 180. So the total number of females is 180. Now it doesn't matter if those females like SUVs or if they like sports cars, we're just looking at the total number of females. And then the total number of cars who prefer cars is the total of this row here, column here, that's 84. So it doesn't matter if the person is a male or if they are a female, the total number of people who like cars are 84. But then we do something that seems maybe a little bit strange, and we take away the 45. So it would be 180, add 84, take away 45. So you kind of think, well, why is it that we're doing that? Why are we taking away the 45? Why are we not just adding it? Well, very simply, just to show you in 2 seconds why it doesn't work as well, is that if we actually added 180, 84 and 45 together, then we would get more than 240. So we know that that can't possibly be right by adding them all together, because we would get more than the total number of people who were asked in the survey anyway. So the easiest way to kind of think about it is imagine we have 2 sets. So we have set 1, and they have these funny curly brackets, that has the numbers 1, 2, 3 and 4 in it. And then we have another set, say set B, which has the numbers 3, 4, 5 and 6 in it. And we want to know what the union is of A and B. So we want to know all the numbers that are in A and all the numbers that are in B. So if we put them down together, and that funny upside U is for union, so we're making a new set, has all the numbers that are in A and all the numbers that are in B. But do you notice something? What do you notice about combining those two sets? Okay, so we have the 3 and the 4 are appearing twice. So yes, they may be in both sets, but we just want to know what numbers are in there, not how many of them are in there as such. So we can write it only including one set of the numbers. So we don't have to write them out twice. And if you imagine this on the Venn diagram, so we have set A here, which has got numbers 1, 2, 3 and 4 in it. And we have set B here, which has got 3, 4, 5 and 6. If we wanted to say, well, what numbers are common between the two sets? So what numbers appear in both sets? We'd have 1 and 2 left here, 5 and 6 left here, and 3 and 4 appear in both sets. But we don't write 2 3s in here, and we don't write 2 4s in there. We only write 1. So the reason why we take away the 45 is because we've already counted the females who like the sports cars by counting all the females in this row and all the sports cars in this row. As you can see, we'll have counted the 45 twice, on this row once and on this column twice. So we need to take away the 45, otherwise we won't have the correct answer. So where you have a question that is asking you for the union of the sets, you must make sure that you take away anything that is common to both sets and you don't count it twice.